All right, hi everybody. Today we are going to focus on sig figs and what are significant figures, and we're going to get a little bit into the math behind it. So we're going to get into adding, subtracting sig figs. So this is something that we're going to use for the rest of the school year. So if this is something that you start struggling with, please, please, please come see me, get some help, because again, every test quiz we take for the rest of the year pretty much is going to have sig figs in some point, especially second semester. And so if you struggle, come talk to me now so we can get ahead of it instead of struggling later. Okay, what is a significant figure? So anytime we do any sort of measurement or anything like that, we always have some sort of error or uncertainty that is going to exist in a measurement because you never know what sort of error lies in there. There could be error with the measurer or the person doing the measuring. There could be the precision of the device. There could be the environment around could be affecting things. And so we never know. There's never a definite 1000% every measurement is completely accurate. And so we have what's known as significant figures. It's a pre-described decimal place that determines the amount of rounding off to be done based on the precision of the measurement. So it's basically saying that all the digits are known with certainty plus one that is estimated. So whenever we say we're going to a certain sig fig, we're basically saying that those numbers are a definite and we know those for sure. That last digit in the number is where the rounding is taking place. So that's where that error is going to occur. And so here's an example of when we would use sig figs. So let's say we're measuring the length of this pencil and we're looking at it, and if we were looking at this any other way, we would say, oh, well, looks like, measuring quickly, 12.7 centimeters. When in reality, it's not quite to the 7. So we would actually say, to be the most accurate we could get for a measurement, we would probably say 12.68 centimeters. And so what we're saying here is that this 12.6 are definite. So those are definite numbers that we know for sure are correct. It's this 8 here is where the rounding is taking place. So if it said do your measurement in 4 sig figs, I would have my 4 sig figs. So I'd 1, 2, 3, and then the 8 would be where the rounding is taking place. And again, we can look at that and we can say, yeah, I totally agree. I know for sure there's a 12 centimeters. I know that for sure there is a 6. But it's not quite to the 7 yet. And so we have to say, well, it's probably 12.68 centimeters if we want to try and get the most accurate measurement possible. So that's what it's talking about when we're talking about significant figures. On the slides, there's a really good video that I highly recommend checking out. And it tends to answer a lot of questions for kids and gives them some other ways to think about significant figures and remember them, because there's a lot of rules that we have to deal with. And so, again, I highly recommend once we get done with the video here, go back to the slides and watch this. It tends to answer a lot of questions. So if you ever get stuck, you can always revert back to that video and it'll give you some helpful hints. Okay, so significant figures. Now, a lot of times our sig figs have a lot of rules, and that's what catches kids a lot. And so we are going to go over a couple of those tough rules that we need to know. So the first one that is not on the slides is any number that is numbers 1 through 9 automatically significant. So that makes life so much easier. So you never have to worry about is a number 1 through 9 significant. It is. It doesn't matter, automatically significant. The problem lies with zeros. Zeros tend to be the headache that make things really difficult. So if we look here, it says zeros appearing between non-zero digits are significant. Again, non-zero digits are numbers 1 through 9. And so if we're looking at A, for an example, we have 40.7 liters. So since this 0 is sandwiched between 7 and 4, it will become a significant figure. So we would have 1, 2, 3 sig figs. Looking at B, we have 87009. Well, these zeros are sandwiched between 7 and 9, and so automatically become significant. So we have 1, 2, 3, 4, 5. So we have 5 sig figs in that number. Again, all because they're sandwiched between two numbers. Zeros that appear in front of non-zeros, so anything that is in front of 1 through 9, are not significant. I like to call these leading zeros. So leading zeros are not significant. They do not get to count as a significant figure. So if we're looking at A, for example, we have 0.095897. And so if we went back and watched that video that I told you to go see, they talked a lot about Pacific versus Atlantic Ocean. Well, the Pacific is on the left side, and so the P stands for decimal present. So if there is a decimal present, you start from the Pacific side of the Pacific side of the United States, and you go inwards until you hit a number. From there, everything behind it becomes significant. So P equals decimal present. Okay, so we go to the front, swim until you hit a number, and then from there, everything beyond is significant. So if we're looking here at A, we have 0.0. Well, I haven't hit a number yet, so I'm going to keep swimming inwards until I hit a number. From there, I hit 9. So there's 1, 2, 3, 4, 5. So it has 5 significant figures. Again, I came in from the Pacific side because there's a decimal present. I swim in until I hit a number, so I hit 9. From there on are all significant figures. Now looking at B, for example, again, there's a decimal present here. So I go to the front, I swim in until I hit a number. Once I hit that number and beyond, behind it, is significant. Well, there's no numbers behind it. So there's only one sig fig. And that's all because there's no number or anything in front of these zeros. So they would consider leading zeros. Now, this is where it can get really tricky. So zeros at the end of a number, but to the left of a decimal point, may or may not be significant. If a zero has not been measured or estimated and is a placeholder, it is not significant. A decimal point placed after zeros indicates that they are significant. So again, those decimals make a huge difference. And so, for example, if we're looking at A, we have 2,000 meters. It can either be 1 or 4 sig figs, depending on what we're measuring and how many sig figs we need to go to. So let's say we have a measurement that was 2001. We'll just say that, 2001. And it says put it into 3 sig figs. Well, if I did that, I would go 1, 2, 3. Look behind, it's a 1, so I'm going to stay the same. Now, we know there's a big difference between 2,000 and 200. So what we do is we put what's known as a placeholder 0. That placeholder 0 is not significant. These 3 are, but that last one isn't. So that's why we would say this number would be 3 sig figs. And that's exactly why when we look at example A, that it could either be 1 or 4 because there's no decimal present. If there's no decimal present, we come from the Atlantic side and we swim backwards. So you go to the back of the number, swim in till you hit a number, and then everything in front of that number is significant. Well, here there's no decimal for A. I swim in till I hit a number, and I only have 1 sig fig. And so now, but if it said 4 sig figs, then you could say it would be 4 sig figs. So it can be kind of tricky with those. Now, if we're looking at B, for example, B has a decimal point here. And so since it's a decimal point, we go to the beginning, swim in until we hit a number, and then everything behind it becomes significant. So that one has to have 4 sig figs. So the decimal point is huge and is super important when you're going through these problems to make sure and check, is there a decimal? If there's not a decimal, you start from the back, swim in until you hit a number, and then from there, everything forward is significant. If there is a decimal, again, go to the front, swim in until you hit a number, everything behind it is significant. Okay, this one is zeros at the end of a number, but to the right of a decimal point are significant. Again, it's still dealing with the decimal points. And so here we have 85. So we have a decimal, go to the front, swim in until you hit a number. Everything behind it becomes significant. So we have 4 sig figs in that number. Now we have 9 point and like a whole bunch of zeros. So what we're going to do, again, there's a decimal point present. So you go to the front, in the Pacific side, go in until you hit a number. That makes everything behind it significant. So there's 10 sig figs in that number. So again, the decimal points make or break sig figs. All right, let's do some practice. So how many sig figs are in the following values? So if we're looking at A does not have any zeros in it. So that's telling me automatically, or wait, hold on, I skipped one. There we go, recap. I knew I was missing something. Recap, these are your main sig fig rules that you will need to know. These do not go away. I am promising you that. They will be here from now until May. Please, 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 if you struggle with these, come talk to me. Let's get it ironed out before we get into some bigger math. And then you're missing silly points on tests and quizzes because you just don't know how to do sig figs. So, important rules. Any non-zero is automatically significant. So numbers 1 through 9, automatically significant. Leading zeros are not significant. Again, leading zeros are your 0.01. These zeros in front are not significant. Only that one would be. Captive zeros are significant. So 101, all of these get to be significant because it's sandwiched between two numbers. And then trailing zeros are not always. It depends. So if there is the difference between 10 and 10 with a decimal, this one can either be 1 or 2. This one has to be 2 sig figs. So again, make sure you know these rules. It's never going away. Okay, now let's go to our practice. So looking at A. So A is 28.6 grams. Again, there's no zeros whatsoever. And so we would say 1, 2, 3. So there are 3 sig figs in that number. Then we go to B. B, there is a decimal point present. So what we're going to do, we're going to go to the front and we're going to swim in until we hit a number, making everything behind it significant. So we have 4 sig figs. Looking at C, 910 meters. Now there is no decimal present. So what we're going to do is we're going to swim from the back end until we hit a number. And then everything in front of it is significant. So there's 2 sig figs here. All right, looking at D. D, 0.04604. Okay, what's going to happen here? We have a decimal present, so we're going to go to the front. You swim in until you hit a number. Again, these are leading zeros. They do not count. Once we hit that 4, everything behind it becomes significant. So 1, 2, 3, 4. There are 4 sig figs in that number. And looking at E, again, we have leading zeros and trailing zeros. So again, but we have a decimal. That's the most important part. Go to the front. Swim in until you hit a number. Then we go 1, 2, everything behind it, 3, 4, 5. So we have 5 sig figs. Okay, so that's just a little practice of how do we figure out how many sig figs we have in a number, because we need to be able to do that to get into the math. So let's do one more quick check. So how many sig figs are in the value of 0.00540900? Okay, we're pretty much seeing all of our rules show up. So the first thing is any non-zero, automatically significant. So 5, 4, and 9, you can automatically count those in. Now the problems are the zeros. And so these zeros in front, these 3, are not significant because they are leading zeros. There's also a decimal point here, so that helps us out. So we go to the front, swim in until you hit a number. So you hit 5. Now we know 5 and beyond automatically becomes significant because there's a decimal present. We also know that this 0 here is significant because it's trapped between 4 and 9. These ones, these zeros in the back, are trailing zeros, and since they're behind the decimal point and behind a number, They're good. They get to count. So we have a total of 1, 2, 3, 4, 5, 6 sig figs. And that answer would be D. Okay, rounding. This is what you've been doing since probably 3rd or 4th grade. And so it has not changed. It's just allowing us to calculate, will most of the time be necessary to round your answers. I will always say, go to 3 sig figs and round for whatever your answer may be. The rule still applies what you've been doing forever of, 5 or higher, you go higher, 4 or lower, you stay the same. And you're just going to increase it by 1. So for example, it says, round this number to the nearest 3 sig figs. So again, we're looking here, we have 42.68 grams. I would go 1, 2, 3. I look behind, it's an 8. So since it is higher, we're going to round up, change 6 into 7, and I get 42.7 grams. Then looking here again, if I'm going to 3 sig figs, start at the beginning, 1, 2, 3. I look behind, it's a 2. Since it's lower than 5, I'm going to stay the same. So I stick to my 17.3 meters. So again, rounding stays the same of what you've been doing forever. So 5 or higher, you go higher. 4 or lower, you stay the same. All right, let's do a little bit more rounding. So practicing rounding with 4 sig figs. So this time, we have to go to our 4 sig figs. Again, we got to figure out what our sig figs are first. So we have a decimal, means we go to the front. I go in until I hit a number. So there's 1 sig fig. The 0 here is significant because it's sandwiched between 2 numbers. So there's 2. That's a 4, so it's significant. And then there's 4. So there's my 4 sig figs. I look behind. And a lot of times you'll see me draw the arrow to look behind. It's a 5. So 5 or higher, you go higher. So I get 804.2 grams. Then we're looking at B here. B, we need to figure out our 4 sig figs. Again, these zeros in the front are not significant. So you start at 1. So 1, 2, 3, 4. Look behind, it's a 3. So we are going to stay the same. Now, when you do this, you still have to write out 0.0 because they're still part of the digit, like start of the number. They're just not significant. So it would be 1, 4, 4, 2. All right, looking at C. Again, we want 4 sig figs, so I'm going in from the front. I swim in until I hit a number. So I hit 6. 1, 2, 3, 4. I look behind. It's a 0. I'm going to stay the same. I'm going to include those leading zeros. So 0.000625. And there's my 4 sig figs. Going down to D, again, I have another decimal present, so I go to the front, swim in until I hit a number. So I hit 3. So 1, 2, 3, 4. I look behind, it's a 5. So I'm going to round up. So I have 3.425. Would be my final answer. So all of these numbers are in 4 significant figures, even though some are going to be longer than others. Okay, let's get into a little bit of math. So depending on what you're doing, so math-wise, whether you're adding, subtracting, multiplying, or dividing, you have different rules you have to follow. For us, we stick to more of the multiplying and dividing section, but we still need to know what to do when we have to add and subtract sig figs. So when you're adding and subtracting decimals, the answer must have the same number of digits to the right of the decimal as there is in the measurements having the fewest digits to the right of the decimal. So basically what that's saying is we want to see how many sig figs there are to the right of the decimal point. Now, when you're solving these problems, solve for the math first. Do not try and do sig figs first. It makes it 10 times more complicated. Just solve the problem first. So if we're doing this example here, 25.1 grams plus 2.03 grams. I'm just going to add those two together and I will get 27.13 grams. And again, I write the whole thing out. Just write the whole number. Anything you get in your calculator, write it down. Then we're going to look at our numbers here to figure out how many sig figs do we need to go to? Now, looking at 25.1, I'm just worried about what's behind the decimal. So adding, subtracting, you worry about what's behind the decimal. So I look, there's a 1, so it's telling me I have 1 sig fig. Looking at 2.03, well, the 0 is sandwiched between two numbers, and this 3 is there, so that's a non-zero digit. So there's 2 sig figs. Now, one thing about sig figs that's helpful in chemistry in general, we want to do the least amount of work possible, meaning we always go to the smallest number of sig figs, just trying to make our life easier. So that means we're going to go to the smallest amount. So what's smaller, 1 or 2? Obviously, your answer is 1. So what's going to happen? I'm going to ignore 27, okay? I'm not worried about what's to the left of the decimal, just to the right of the decimal. So again, I'm going to 1 sig fig. I look behind, it's a 3. Are you going to round up or stay the same? You're going to stay the same because it's 4 or lower. So my final answer here would be 27.1 grams. Again, solve first, look at your numbers, figure out how many sig figs, always go to the least amount, and then put your final answer in sig figs. Okay, so let's solve this one. So we have 5.44 meters minus 2.6103 meters. So when you do that, you can plug that into your calculator, whatever it needs to be. You should get an answer of 2.8297. Okay, now I gotta figure out how many sig figs am I going to? And again, you always go back to your problem to figure out how many sig figs. So I'm looking at 5.44. Again, I'm just worried about what's behind the decimal. Well, I have 1, 2. So I have 2 sig figs here. And I have, looking at 2.6103, I have 1, 2, 3, 4. And again, that 0 is significant because it's sandwiched between two numbers. So there's 4. I always go to the least amount, so I'm going to go to 2. Again, I'm going to ignore the 2 in the front to the left of the decimal. I'm just going to go behind it. I go 1, 2. I look behind, it's a 9. And I'm going to round up because it's 5 or higher. So it's 2.83 meters would be my final answer. Now looking at 87.3 centimeters minus 1.655 centimeters, when you subtract those two, you should get an answer of 85.645. Again, solve it like normal. Just plug it into your calculator, solve it. Now we worry about sig figs. I go back to my problem. I look at behind the decimal. Well, 87.3 just has the 1 sig fig, so there's 1 here. And then we have 1.655. We have 1, 2, 3 sig figs here. I always go to the least amount, so I'm going to go to 1. Again, I ignore the 85. I just go to 6. I look behind. It's a 4. So I ask myself, am I going to round up or stay the same? Well, it's 4 or lower. So I'm going to keep it as 85.6 centimeters. Okay, last but not least, 2.00 or 2.099 grams plus 0.05681 grams. Again, solve it first. Plug it into your calculator. When you do that, you should get 2.15581. Okay, now we got to figure out how many sig figs are we dealing with. Again, this 0, looking at 2.099, that 0 gets to count as a sig fig because it's sandwiched between two numbers. So we have 1, 2, 3 sig figs. While looking at 0.05681, these zeros here do not get to count as significant because they are leading zeros. So our first 0, or our first sig fig, starts at 5. So 5, 6, 8, and 1. So there's 4 sig figs here. Again, we go to the lowest amount, so we're going to go to 3. Again, we ignore the 2 in our answer. We just go to the right of the decimal. We go 1, 2, 3. I look behind. It's an 8. So I ask myself, am I going to round up or stay the same? Well, 8 is higher than 5, so we're going to round up. So it's going to be 2.156, and that would be grams. Would be my final answer. Now, is it always going to be the first number? Going to be the number of sig figs you go to? No. So always double check as you're going through these and make sure you're saying them up correctly. The biggest thing when adding and subtracting sig figs, solve the problem first, figure out who has the least number of sig figs, and then round your decimal place. Again, we're only dealing with decimal places. We're not dealing with the whole number. Okay, just the decimal place, just behind the decimal, just to make our life easier. All right, so that's all I have for you today. If you have any questions on this, please, please, please let me know so that we can get this straightened out. Again, it's not going away anytime soon. So seriously, if you have questions, please let me know. But have a great rest of your day. I will see you tomorrow.